Okay, 5-4, day 2. Remember, we're still using power reducing identities, double angle identity, half angle identity. Those you'll have a sheet on for the test, but you gotta know how, you gotta be able to manipulate them. For example, I've got sine 2x equal cosine x. Remember, sine 2x, if I'm looking at the double angle, that's the same as 2 sine cosine x in this case. Okay, equal cosine x. Now, I'm solving. I am not writing an identity. The difference, when I solve, I get to cross the equal sign and let things mix. I don't have to make it look like the other because I'm actually solving this. So now I'm going to get everything over to the left. Equal to 0. Now I'm going to factor out a cosine x. I forgot an x in there too. Sine x, and that is -1. Sorry. Had to look where I was, making corrections as we go. Bring that down, maybe, possibly. There we go. So now I use zero product rule. It's either this or it's this. Okay? And now cosine x, well, is 0. Cosine is 0 in 2 different spots here. Cosine is 0 up here at pi over 2, because that's 1, 0, 0, 1. And 3 pi over 2, that's 0, -1. Okay, so those are the 2 places. Cosine is 0. Right? Now, I've got here sine of x equal 1/2 after I add 1, divide by 2. So I got to be thinking, where is sine 1/2? So my answer for sine being 1/2 are pi over 6, which is the square root of 3 over 2 and 1/2, and 5 pi over 6. If I could squeak that in there, 5 pi over 6. We'll clean that up and I'll write it in there and we'll put it back in. So I got 5 pi over 6. As we clean that up, 5 pi over 6, and that is negative square root of 3 over 2 and positive 1/2 as I finish that out. And so that stuff goes back in there. 5 pi over 6 is right there. That's really clear. Sorry about that. We'll just put it up there and I'm going to put a line to it. Okay. Now, so keep in mind I got pi over 6 and then 5 pi over 6. Now I'm going to check and read what I'm supposed to do. The intervals between 0 and 2 pi, not including 2 pi, that's what that parenthesis means. So x, my values of x are, and not necessarily in any order, I've got, well, sure, why not? Let's put it in an order. Pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. So I got my solution set. Okay. Now remember, this wasn't all solutions, it was just solutions between 0 and 2 pi. We will get to all solutions in a sec here. Using half angle identities, solve. Gosh, that was even faster than I thought. All solutions here. So using the half angle, I got to keep in mind, I look at my sheet and I look at 2 sine squared x, but really it's sine squared x, and that sine squared x is 1 minus cosine. As we're going, I'm going to use that half angle, right? It's half angle identity, so I'm talking about a half, and I'm totally pulling up that sine plus or minus the square root of 1 minus cosine x, but I've got 2 times square root of 1 minus cosine x. Now keep in mind that's supposed to be squared as I go through, okay, because I'm using that half angle to get it back to x. All right, so now this is sine 2x, so or sine squared x, is equal to 2, and I'm going to do this kind of slow, 1 minus cosine x over 2. That plus or minus went away with the squaring. And now this is cancels each other out, so I've got sine squared x as I'm stepping through. Oh, let's make that change. That sine squared x is 1 minus cosine squared x. As I go through, I get 1 minus cosine x here. Now I'm going to kick this stuff here over on this side to the right. So I've got 0, and I'm going to put over there negative 1 plus cosine squared x plus 1 minus cosine x. Okay. And this ends up being cosine squared x minus cosine x. And now I've got cosine x, I'm factoring that out, times the quantity cosine x minus 1. So those are my two things I'm going to solve for using zero product rule. So now, keep in mind, I'm going to look to find cosine x is equal to 0 when, and also cosine x minus 1 is 0 when. So I'm looking for the zeros of cosine x, and remember, we just kind of did the zeros of cosine. Okay, cosine being 0 is pi over 2, and 3 pi over 2. Okay, so those are the zeros from my cosine. But keep in mind, as we do this, they didn't give me a range. So I'm looking at these being, and I'm going to give myself some space here, pi over 2 plus 2n pi, because coterminal angles, other coterminal angles would bring it back to pi over 2. 2n, and then 3 pi over 2 plus 2n pi. I suppose I should have said that these were equal to x. Somebody's got to actually say that. So x is equal to, and x is equal to. Now let's do this other one down here. I'm going to get rid of that, and I'm going to do it in a different color. So I've got cosine x minus 1 is equal to 0 when cosine of x is equal to 1. Well, the cosine of x is equal to 1 in one spot, and that's going to be, I could talk about it 0, okay? And remember, when I first find these, I'm just looking between 0 and 2 pi. I'm not including 2 pi. But then if I have coterminal possibilities, I need to make sure I show those, and somebody has to be more exact about his notation. So cosine x just being 1 is right here at 0, which is 1, 0. Okay, so I'm really looking at 0 plus 2n pi, or I could just write 2n pi. So my answers here are kind of set. X is equal to my solution set of pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi, and 2n pi. Okay, so that's my solution in this particular interval. Now, this next one is kind of an interesting thing. As we go through, we're going to show you something to make it easier to solve instead of writing, using a bunch of identities and getting it down to sine of x, or so we can get x. There is a neat way to look at that b value, and as we go through this one, we're going to show you how to use it. But the first thing I want you to do is get in the habit of looking at it and go, hey, that's what does the 2 times the sine of x minus 1 look like? Okay, I'm going to solve it with that in mind. Okay, so I'm going to wonder, first of all, when is sine of x equal to 1/2? So I'm going to find the places on the unit circle where the sine of x is 1/2. Okay, I'm going to find those x values where the sine of x is 1/2. So keep that in mind as we're going through this. Okay, so now, I know it says 3x, be patient with yourselves. Right now I'm thinking sine of x. So where sine is 1/2 is pi over 6. So at pi over 6, I have the square root of 3 over 2 and 1/2. And 5, I said pi over 6 and I wrote pi over 3. Someone's got some issues today. Let's fix this. Okay, so pi over 6, okay, so this is pi over 6 as we're going through. Okay, that's our pi over 6 and 5 pi over 6. 5 pi over 6 is negative square root of 3 over 2 and 1/2. So now, as we go through this, you want to make sure you recognize that we're looking for sine of 1/2. So I've got my pi over 6 plus 2n pi. And again, I did it again. Pi over 6 plus 2n pi. I also have the idea of 5 pi over 6 plus 2n pi. Now, keep in mind, we found for when sine of x, but this is 3x. So how is Bloom going to do this? How would I make that x? Wouldn't I just divide by 3? So let's divide our value by 3. And people are like, what? So watch what happens, dividing by 3. So that pi over 6 becomes pi over 18, because I'm dividing by 3, same as multiplying by a third, plus 2n pi over 3. Okay, now this one's the same. X is equal to 5 pi over 18, multiplying everything by 1/3, plus 2n pi over 3. Now, this was a lot neater way of looking at this problem as I step through, but now we got to talk about my different answers as we go through this, okay? Because what we've got is an interval, okay? So on this interval, in this first one, this first grouping, I've got pi over 18 plus pi over 18. And I'm going to be adding, and you got to keep in mind, I'm going to be adding different versions of pi. So let's just get things right here. This is pi over 18. This is the same as adding 12 and pi over 18s. And this is the same as 5 pi over 18 plus 12 and pi over 18. So I'm going to add versions of 12 to the problem. So I got pi over 18, as I look it over, pi over 18. So I got pi over 18 plus 12 pi over 18, which is 13 pi over 18, plus 12 more pi over 18, which is 25 pi over 18, and plus 12 more, which is 37 pi, which is greater than 2 pi. So these are my only three solutions from pi over 18. And now in the next section, I'm looking at the idea of 5 pi over 6, or 5 pi over 18, excuse me, and I'm going to add 12 pi over 18s until I get to or past 2 pi. So 12 pi over 18 is the same as 17 pi over 18, which is 29 pi over 18, and if I go one more, that becomes 41 pi over 18, which is more than 2 pi. So those are my solutions for this problem, right here and here, using the shortcut, okay? Versus running through and writing a identities for this problem. Now in this next one here, we're going to do the same thing, okay? Except it's x over 3. So now I'm going to go through and run through, and I've got 2 cosine of x over 3. Remember, I'm going to treat that kind of like it's x in this problem. Equal negative square root of 3. Divide by 2. Negative square root of 3 over 2. Okay. Now I'm going to look for the spots where my x value would be the negative square root of 3 over 2 for my cosine. Now, negative square root of 3 over 2 is back here. Okay, and it's up here or down there. This is 5 pi over 6. It's really close. The board is kind of funky. 5 pi over 6 and 7 pi over 6. Both have a negative square root of 3 over 2. One has a negative 1/2, one has a positive 1/2. Okay, so those are the two answers I'm looking for. So again, just like I did, I have my two things. I'm looking at 5 pi over 6 plus 2n pi, and I'm also looking at x over 3, 7 pi over 6 plus 2n pi. At this point, I am just going to multiply all the way across by 3. Okay, so as I multiply across by 3, you got to keep in mind x is equal to 5 pi over 2 as I reduce, plus 6n pi. Okay, and x is equal to 7 pi over 2 plus 6n pi. So multiples of 6n pi. Now, because it's so big, okay, and we've slowed it down. I mean, when you look at the problem, you're like, well, why can't I find a solution right now? These are possible solutions, but they don't exist between 0 and 2 pi. Because I want you to pay attention to the fact that this is 2.5 pi. This is 2.5 pi away. This is 3.5 pi away. Okay, so they are not inside our interval. So there is no solution here in the interval given between 0 and 2 pi. Okay, and I want to make sure that you recognize that that first solution is at 5 pi over 2 and 7 pi over 2 respectively. And keep in mind, we have a horizontal stretch of our graph because we've just extended it out because our b value is 1/3. Okay, so now going on to our next problem, our last one, I have sine of 2x equals sine of 4x. Okay, so if I get this back and I got sine of 2x, it's equal to, excuse me, minus sine of, hey, let's dress that up like this because it's a double angle identity. And now I'm looking at this idea that I have sine of 2x minus 2 sine of 2x cosine 2x is equal to 0. And now I can factor out my sine of 2x. So I have a sine of 2x factored out, so it's 1 minus 2 cosine 2x equals 0. And then I go for my solve. So now I got to find when, again, using the idea that when is the sine of x 0. So I got to find when my sine of 0's. And my sine is 0 at 0 and pi. Okay. As I go through, and this is, remember, negative 1, 0, and this is 1, 0 as I step through those. So I've got 0, and my setup here would be my 2x would equal 0 plus 2n pi, and my pi, my 2x would be pi plus 2n pi as I'm going through there. And now I just go ahead and look it over and say, well, I'm going to divide by 2, and that's going to be equal to n pi. And this divide by 2 is pi over 2 plus n pi. Okay, that's pi over 2 plus n pi. Okay, that's the first one. The next one, I'd be talking about the idea of 1 minus 2 cosine 2x equals 0. And this is when 1 is equal to 2 cosine 2x. So 1/2 is equal to cosine 2x. So when is cosine 1/2? And cosine is 1/2. Here, up here, as we go through, I got pi over 3, where I've got my cosine there, and I got pi over 2, 3, 4, 5 pi over 3 down here. Excuse me, 5 pi over 3. So as we go through, I've got 2x is equal to pi over 3 plus 2n pi. And I've got 2x is equal to 5 pi over 3 plus 2n pi. And as I'm stepping through those, I'm still looking at the idea that I've got to solve these two. So I've got x is equal to, dividing by 2, multiplying by half, pi over 6 plus n pi. And I've got x is equal to 5 pi over 6 plus n pi. Now let's talk about my intervals to my solution. Since I've got this going, I got 0 and pi going up there, and I'm supposed to solve on the intervals from 0 to 2 pi. And I've got pi over 2 to 3 pi over 2. And here on this next one, because I'm going from 0 to 2 pi, I'm looking at pi over 6 and adding 6 pi over 6, I got 7 pi over 6. And then if I go again, I'm beyond 2 pi, because I'll be 13 pi over 6. And here I've got 5 pi over 6. And I have 11 pi over 6 with multiple addings of what I'm doing. Hopefully everything's going well, but remember we've got our answers here at 0 pi, pi over 2, and not in any particular order. I'm just writing them down because I got a class to start. And these are my answers. Hey, the assignment's there online and it's here. So make sure you're getting them done and have yourself a great day.